Hi, this is Professor Slaughter once again, and we're going to go over a few of the concepts that are being discussed in Chapter 4, which is essentially our first time value of money chapter. Now, I want to stress at this point that if you think you're going to get out of this class without practicing, then you are going to find yourself very disappointed in your grade. This class does require that you study. Unless you've got a already existing foundation in finance, this class is going to require that you take some time to master the principles. So we'll be doing a lot of repetition in class, and hopefully in these videos I can steer you in the right direction when it comes to working these problems. But this is going to be one of those things that we're just going to work through together to make sure that you're mastering the principles. So in this video I'm going to go over primarily the difference between simple interest and compound interest, and then we're going to look at some formulas and timelines. And hopefully once you read the chapter and you work a few problems, then you'll be able to see how these formulas are employed. Certainly if it becomes necessary for us to go into a little bit greater detail, then I will certainly generate that information in those videos later on in the week. Okay, so let's get started. First of all, on the difference between simple interest and compound interest, and it's really pretty easy. Simple interest is interest earned on the principal portion only of the investment. It doesn't matter how long you leave it in the bank. For example, if you put $100 in your savings account and you earn 5% a year, then you are only going to earn 5% every year, or $5 every year in interest, because it's just simple interest on the money that you have put in there to save, the principal portion, and it is not interest on interest, which would be compounding interest. Interest is earned on the principal and any earned interest each period. For example, if you put $100 in your savings account and earn 5%, you're going to earn $5 in year one. But if you don't take that $5 out, then in the following year, that your interest is calculated on $105, which means you'll earn $5.25 in year two. So the difference basically between simple interest and compound interest is whether or not you're going to earn interest on interest. And so as investors, as savers, we want to always get our hands or get our money into a compounding account of some type when we put our money away in banks. Okay, so let's review these future value formulas that are mentioned in Chapter 4. Okay, and I'm going to go over these to make sure that we understand what each formula is doing from a mathematical standpoint, and then I'm going to show you in a little bit more depth what the timeline will look like. Okay, if we're doing a calculation for future value and it's just for one period, like 1 year, 1 month, 1 week, then what we're going to do is we're going to use that first formula that's just for one period, and that is future value equals whatever the present value is times 1 plus the interest rate. And that formula you use only when you're dealing with one interest rate over one period. Then the second future value formula that we're going to be working with pretty soon, future value. This particular second formula is for multiple periods at a stable interest rate. So if the interest rate isn't changing, then you can use the same I over and over and over, right? So your future value is equal to the present value times 1 plus the interest rate raised to the number of periods, or raised to the nth. And then the final future value formula is one that we use when the money is going to be invested in multiple periods, and each period is going to carry a different interest rate. So that would mean you're getting maybe 5% in year 1, 6% in year 2, 3% in year 3, 5% in year 4. So under those circumstances, what we're going to use is a more elaborate future value formula, which basically means the future value is equal to the present value times 1 plus the interest rate for period 1 times 1 plus the interest rate for period 2 times 1 plus the interest rate for period 3. And you can only use this when you have multiple periods at different interest rates. Now when we go into looking at this future value formula 1, okay, this first formula, your timeline is below. And let me see if I can write on this a little bit. If I fail, I will practice the next time. Let me use pen. We'll see how I do here. Okay, so you'll notice in this timeline we basically have one period, and that period extends from 0 to 1. It's not letting me do a pointer. Okay, I've got my ink color. Bear with me just a second while I play around with this for just a second. Okay, I see what it wants me to do. Let me see if I need to write on this screen. Is it letting me? There we go. I don't really like the way it's how it's doing on this screen, but we'll work on this and make it a little better. So you see we're looking at the period of time between 0 and 1, and that is our N. What a pathetic looking N. And then our interest rate is just this one single interest rate at 5%. And what we want to do is we want to calculate the future value, which is here. So we're going to take this $100 and we're going to move it forward to period 1 using this formula and a 5% interest rate. Okay? All right, so let me do this again so it's a little bit neater, since I think I've got the hang of it now. Okay, so we're talking about, this is just for one period. So the one period we're talking about is from period 1 to period 2. That is our N. Okay, so we don't really need to raise this formula to the nth because we know that we only have one period. So all we're basically looking for is this I, which is right here, this 5%, and we're looking at the present value, which is at the PV end of the timeline right there at 100. So when we work this formula, we'll see how well this goes. I may never do this again. Okay, so we have the future value. It's going to be equal to 100. Woo! I'm trying, guys. Times 1 plus plus 0.05 raised, it would be to the 1. Okay, but we're only looking at one period, so it's not necessary to do it. So this is how you would solve this problem. So when we go to the next level, we have 100 times 1.05. And that's how you would solve this. And then your future value, when you total it all up, would be $105. So that's what your question mark would be. That would be your future value based on using this one formula. Okay? So let's move to the next one. Okay, so in the next one, this is the formula that I just told you about that you use when you have multiple periods at a stable interest rate. And what I mean by a stable interest rate is that this interest rate is going to stay consistent every year. So again, in this formula, we're looking for our present value, which in this formula is, or in this timeline, is still $100. And our interest rate right there is stable. We have a 5% here, and we have a 5% here. The only thing that's different is that we have an N here. And because we are going for 2 periods, we know that our N is equal to 2. Okay? So when we calculate this up, we're basically doing the same thing that we did before. We have our future value is equal to 1. I'm going to be so good with this by the end of the semester. 100 times 1.05, which is 1 plus the interest rate, raised to the nth, which is a 2. Okay? And when we go to solve this problem, the first thing that we're going to do is we're going to deal with that 105 and that exponent. So we're going to have 105 raised to the second, because it's 2 periods, and that gives us 1.1025. All right? And when we go back and we multiply that times 100, in this particular investment, our final answer is $110.25. All right, now it's going to get a little bit more challenging, but it's still no big deal. We're not going to have room on the slide to work this, but it'll make sense. Okay, so we're dealing with multiple periods at different interest rates. And you can see that we have more than one period here, and we have a 5% interest rate in one year and a 6% interest rate in another year. Okay, so our present value, which is right here, is still this 100 right here on the timeline. And then we have our interest rate for period 1 is 5%. Then we have our interest rate for period 2 at 6%. And I just want to draw this to your attention. This is multiplication and this is multiplication. Don't be adding these things. It's a very, very common error. Okay, so then the way we're going to set this up is we're going to say future value is equal to our present value of $100, which we see on our timeline, and we're going to multiply it by 1 plus the interest rate for period 1, which is 5%. We can see that right there, so it's 1.05. And then the next thing we're going to do is we're going to multiply it times 1 plus the interest rate of the second period. And if we had different interest rates going into years 3, 4, and 5, then we would just keep multiplying them out. And when we multiply 1.06 times 1.05 times 100, we get $111.30. Okay, now I'm going to go ahead and switch over to the next slide, which goes over to the present values, some of which we didn't really go over present values in class, and I am going to be setting these up for you just the exact same way that I did with the future values. So if we look at the initial present values, we have the same rules here. This is the formula that we use when we're working with just one period. This is the formula that we use when we have multiple periods at a stable rate. And basically the only difference between this formula here and this formula here is the N. Right there. That's the only difference between these two formulas. And then of course if we have multiple periods at different interest rates, then we use the more elaborate formula. Now there's a way to calculate these in the calculator, and we will certainly, the book explains to you how to work that through the BA2 Plus as well as in Excel. Alright, so let's look at this first one. Okay, you'll notice that we can use the formula above only because we have one period, and one interest rate. So all we're going to do is we're going to take our future value of $105, and then we're going to divide it by 1.05, which is 1 plus the interest rate. Fairly easy stuff.
That was easy.
So this is the first formula that we're going to be using, and then when you solve this all the way through, you end up with the original $100. And this, by the way, is called discounting because you're going backwards toward present value. Okay, same thing with this other formula in present value for formula number 2. Okay. Again, it's just like the formula we just worked with. The only difference is we have more than one period. So when you load this up, you're going to use, let's say that, I can't remember, oops, hold on just a second. Hold on just a second. right, so in this formula we have only one interest rate, but we have two periods. Okay, so this is we're not really going toward a particular value here. If we assume the same interest rate for both periods, which is 5%, we would have to know the future value. So let's just, because this doesn't have a future value on it, let's say that the future value is $115, okay? We'll just put that there. So if we consider this our FV, okay, on this end, all right, and we take the $115 and we divide it by 1.05 raised to the second, because it's two periods, then what we're going to end up over here with is 104,3084, or basically $104.31. That is the present value of $115 invested for 2 years at 5% interest. Okay? All right, in this one, this is a little bit tricky as well, but again, it's just because we have, this is very, very similar to the future value one that we just went over. We're dealing with this formula because of this situation right here. We've got two different interest rates in two different periods. So what we're going to do is we're going to take the future value, which is at this end of the spectrum at $1,000. This is our present value side of the equation. And we're going to solve this rather simply with putting our future value on the top, okay, as the numerator, because that is our future value. And then we are going to multiply together 1.05, 1 plus the interest rate, times 1.06, and if we were going 3 or 4 periods in the future, we would just keep going. So what we end up with, 1.05 times 1.06, we end up with 1.113. And then when we divide 1,000 by 1.113, we end up with a present value of $8.98 for $898.47. That's pretty pathetic. 898.4726, which is basically $898.47. See if I can do my little congruent sign here. Okay, so basically all you're doing is you're drawing timelines and you're applying the formulas. So, and this is something that you're going to have to do. It's going to take a little bit of trial and error, but as long as you're drawing your pictures, picking the right formulas, and then working through your formulas in accordance with the orders of operation, you shouldn't have any problem. Now, as you know, this covers part of Chapter 4. We've got other information coming up on time value money in Chapter 5, and that will be under a separate video.